Oh, hello. Didn't see you there. Welcome back. Today we are going to be talking about a new way of measuring angles. Now you might have covered this and remembered some of this from Algebra 3-4, but it is worth reviewing. Of course, we know for a circle that there are 360 degrees in a circle. We know that. We're cool with that. Today we are going to talk about a new way of measuring angles. All right, what we have here is a circle with a radius of 1 lanyard. Okay, so this circle has a radius of 1 lanyard, and we're going to define a new way of measuring angles. Similarly, you might have remembered for degrees, we can start at 0. So this is going to be 0 right here. You have heard the term radians before, and when we talk about radians, a radian is defined as the angle swept out by one radius along the circle. So if I take the radius and I put it along the circle, I will get around about right here. And this is 1 radian. Radians are another way of measuring angles, and 1 radian is the angle swept out by 1 radius along the circle. So it's worth thinking about then, if we know there's 360 degrees in a circle, how many radians are in a circle? That is, how many times will the radius fit around the circle? Maybe we're thinking about for a second. How many times will this radius fit around the circle? So here we have it, that a radius laid alongside the outside of the circle fits around my circle 6 times and a little bit. Or another way to think about that is if we think about, really we're trying to divide the circumference of the circle by the radius, right? So in this example, the radius was 1 lanyard. So my circumference, we know, would be 2 pi times the radius, but in this case that was a lanyard. So the circumference here would be 2 pi times lanyard. And if I'm trying to divide the circumference by the radius, again in this case lanyard, by dividing the circumference by lanyard, really what I'm doing is doing 2 pi lanyards divided by lanyards. And we could see that the lanyards cancel each other out. We're left with 2 pi, which we know pi is 3.14. So 2 times 3.14 is 6.28. Since that would be 6.28 times the lanyard would fit around the circle, means this is an additional 0.28. Or you might have heard before that in a circle with 360 degrees, 360 is the same as 2 pi radians, just 6.28 radians, because a radius fits around a circle 6.28 times. We can use this information, and you've seen it used before, to mark new ways of thinking about radians and angle measures. So here again, when we start in degrees, we've got 0 degrees. And of course, 0 degrees is also the same as 0 radians. And we know if I start there and I go all the way around the circle, I know all the way around and I have gone 360 degrees. And again, if we're thinking about how many radiuses does it take around there, the answer was 6.28, or 2 pi radians. Which is why we are going to use pi, because it's connected to the circumference of the circle. If all of the way around the circle was 2 pi radians, of course, then it follows that halfway around the circle was pi radians. all the way around is 2 pi, halfway around is pi. Similarly, if all the way around was 360 degrees, we could also say that halfway around was 180 degrees. Continuing that logic, of course, we get that then half of 180 we know would be 90 degrees. And in radians, instead of pi radians, it would be half, right? It would be pi over 2 radians. Here is your task. Based on this definition of radians, I want you to fill out the radian and degree measures for each of these purple lines. To be clear, those purple lines are cutting my quadrants in half. Pretty simple, I hope. Pretty straightforward. Again, we are building a unit circle steeped in our understanding of trigonometry and angles. I look forward to seeing your work. Let me know if you have any questions.